private island under moonlight, a wedding celebration, laughter and music. But then, shards of glass on the floor, a priceless necklace, gone without a trace. Only 30 guests, but secrets run deep. Wine bottles counted, power flickers, sensors silent. An inside betrayal hides in the shadows. Step closer. Together, we will uncover the truth.
Hello and welcome to another data crime story. We are going to use real data to solve this crime case together. First, we need to gather all our evidence. We'll load 4 key datasets: the power outage log, the wine inventory, the boathouse sensor log, and the guest alibis. Each one could hold a clue. Let's see what secrets they reveal. First things first, I'm importing Pandas as PD. Think of Pandas as our digital magnifying glass. It'll help us sift through all the evidence, one clue at a time. Let's start by loading the power underline outage logs. I'm reading in the file called power underline outage underline log.csv. This will show us exactly when the lights went out and maybe, just maybe, who took advantage of the darkness. Next up, I'm pulling in the wine underline inventory records. If someone tampered with the bottles or slipped away for a drink, this data could reveal it. Every bottle accounted for, or not. Now let's check the boathouse underline sensor logs. I'm loading the sensor data to see if anyone snuck out to the docks while everyone else was distracted. Sometimes the smallest blip in the data is the biggest clue. Finally, I'm bringing in the guest underline alibis. This file holds everyone's story, where they said they were and when. We'll see if their tales hold up against the cold, hard data. Now let's dig deeper into the power outage log. We want to know exactly when and where the lights went out. This could show us when the thief had a chance to strike. First up, we're making sure the time column in our power underline outage data is in the right format, turning those strings into real timestamps. That way, we can line up exactly when the lights went out on the night of the crime. Let's take a look at the power underline outage data frame itself. This will show us all the blackout times and maybe, just maybe, reveal a window when our suspect could have made their move. Look closely at this clue. The main outage hit both the bridal suite and the boathouse at 21:15, lasting 7 minutes. That blackout could have given someone the perfect cover. But what else happened during this window? Let's keep investigating. Next, let's check the boathouse sensor log. Did anyone sneak into the boathouse during the outage? We'll look for motion or door activity at just the right time. First things first, I'm making sure our boathouse underline sensor's time column is in the right format. By converting it to a proper date and time, we'll be able to line up every movement down to the minute. This could be the key to spotting when something unusual happened. Now let's take a look at the boathouse underline sensor data itself. Here's where we'll start searching for any odd activity. Maybe a door opening at a strange hour, or someone sneaking in when they shouldn't be there. This is where things get interesting. The sensors picked up motion and a door opening at 21:16 and 21:18. That's right in the middle of the outage. Someone was definitely in the boathouse when the lights were out. But who? Let's find out. Now let's review the guest alibis. Who was unaccounted for during the outage? We'll look for anyone near the boathouse with no confirmed alibi. This could narrow down our suspects. Let's start by pulling up guest underline alibis. This variable will hold all the stories our suspects told about where they were during the crime. It's our first step in checking who might be hiding something. Look at this. Marco Rossi was last seen at 21:17 in the boathouse with no confirmed alibi. Liam Patel was last seen at 21:20 in the garden, also with no alibi. But Marco's timing matches the sensor log exactly. Is this just a coincidence or something more? Let's check the wine cellar for more clues. Let's analyze the wine inventory. Was there any unusual activity in the wine cellar? Sometimes a distraction can help cover up a crime. First things first, I'm typing out wine underline inventory. This will be our starting point, the master list of every bottle in the cellar on the night of the crime. Let's see if anything's missing or out of place. Here's what stands out. Champagne dropped sharply from 8 to 2 bottles by 21:10 just before the outage. Sophie Dubois was last seen in the wine cellar at 21:15, but her alibi checks out. Maybe the wine cellar was just a distraction. Now, let's put all the key events on a timeline to see the bigger picture. First things first, let's set up our detective's toolkit. I'm importing Seaborn and Matplotlib so we can visualize the timeline of our crime scene. These libraries will help us spot patterns and outliers in the evidence. Now, I'm setting a base date, January 1st, 2025. This way, all our timestamps line up on the same day, making it easier to compare what happened minute by minute on the night of the incident. Here's a handy function called as _dt_hm. It takes a time like 21:15 and turns it into a full date time object anchored to our base date. This lets us plot every event on the same timeline, no matter how the data was originally formatted. Let's give our charts a clean detective style look. I'm setting the theme to white grid, so every clue stands out against the evidence board. Time to lay out our canvas. I'm creating a figure and axis, basically the space where we'll map out every suspicious movement and alibi. Alright, let's mark the window when the power went out. That blackout could be the key to our mystery. I'm setting out underline start to 21:15. That's when the lights first flickered off. We'll use this as the beginning of our blackout window. And now, out underline end is 21:22, when the power came back. This 7-minute stretch is our prime time for suspicious activity. Let's shade in that blackout window on our timeline. I'm adding a gray span from out underline start to out underline end so we can see exactly when the cover of darkness fell over the boathouse. Now let's turn to the boathouse sensor logs. These motion detectors might have caught someone sneaking around during the outage. I'm creating a mask to filter out every time the boathouse sensor detected motion. Basically, we're zeroing in on moments when someone was moving inside. Here, I'm building a new data frame called df_motion. It records the exact times motion was detected, sets the y value to 1 for plotting, and labels the series as boathouse motion. Each point is a possible clue. And that closes out our motion data frame. Now every movement in the boathouse is ready to be plotted on our timeline. Let's plot those motion events as bold dots on the timeline. Each circle marks a moment when someone or something was moving in the boathouse. Could this be our suspect? Time to check the guest sightings. We'll label each guest just above or below the line so we can see who was near the boathouse and who might have an alibi. I'm making a copy of the guest underline alibis data frame, calling it guest underline df. This way, we can safely annotate and plot each guest's last known location. Now, I'm converting each guest's last seen time into our timeline format. This lets us line up their whereabouts with the blackout and motion events. Here's a clever trick. If a guest was seen at the boathouse, I set their y value to 1.1, just above the line. If not, it's 0.9, just below. This way, we can instantly spot who was where. Optional step, I'm adding tiny points to anchor our guest labels. It's a subtle touch, but it helps us keep track of every alibi. Let's plot those guest sightings. Each small square marks where and when a guest was last seen. A breadcrumb trail leading us closer to the truth. Now, for each guest, I'm adding their name right on the timeline. With a little tilt for style, we can see exactly who was where and when. No detail escapes our notice. Let's polish up the chart. Time for some finishing touches to make our evidence board crystal clear. I'm removing the y-axis ticks. We don't need numbers here, just locations. This keeps the focus on the timeline and the suspects. Let's label the x-axis as time. Every minute counts when you're piecing together a crime. And the y-axis gets labeled event location, boathouse versus other. This way, we can instantly see who was near the scene. I'm giving our chart a title, Timeline of Key Events. This is our master map of the night's mysteries. To keep the timeline readable, I'm setting up automatic date locators. This spaces out the time labels so we don't miss a single clue. And I'm formatting the x-axis to show hours and minutes. Perfect for tracking every suspicious movement down to the minute. Let's add a legend so we know which dots and lines represent motion, guest sightings, and the blackout window. Every clue has its place. Finally, let's reveal the full timeline. Alright detectives, here's what the evidence tells us. The power outage at 21:15 gave the thief a perfect window. The boathouse was accessed during the blackout, with motion detected at 21:16 and 21:18. Marco Rossi was last seen at 21:17 in the boathouse, with no confirmed alibi. The wine cellar activity seems unrelated since Sophie Dubois' alibi is solid. So, our most likely suspect is Marco Rossi. He had the opportunity and no one can vouch for him. The data points straight to Marco as the probable thief. What do you think? Would you accuse Marco, or is there another angle we missed? The case is in your hands.